Okay, we should be live. Okay, we will need the following data files. Wow, we need a lot of files. Do not run until you. Okay, so first question is always personal. Oh, just the first question, not the second. Okay. So second question is, given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? 90% of all people have a heart rate between 45 and 105. We're 90% confident that the true mean heart rate is between 45 and 105. 90% chance a sample, there is a 90% chance that the true mean heart rate is between. Okay, I will say the second.
Yeah, the second one.
Cool. Daniel, do you want to read the next one?
Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go or no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go-no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied?
Well, it's normal distributed, so that is one requirement that is met.
And it's random, so.
Yeah, the company needs to check that all the data combined is normal. Samples normal, system data have been. I think the third one is the correct answer. What do you guys think?
I think so.
Okay. I don't remember hearing anything like too much about in these lessons about the central limit theorem. So I'm gonna go with the third one. So.
Well, yeah, because like we're constantly using it, you know. It's like.
Okay.
So we go with the third one?
Yes, the third one.
Yeah. So question number 4, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Poor girl. So I gotta read that again. Sorry. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Confidence interval for the mean of differences using dependent samples. Confidence interval for when sigma is unknown. Confidence interval for the difference of mean using independent samples. Okay, so they are independent samples. So interval for difference of means. I will say the third one. What do you think?
I mean,
Daniel, I cannot hear you, Daniel, because you mute your mic. So when you are gonna talk, just.
Yeah, so I think there are 2 groups and they're not related to each other.
Yeah, that's what I think.
They're not like connected, so I think you're right.
Mm-hmm. Yeah, so it shouldn't be dependent. Mm-hmm. So I will say the third one because it's like independent samples and we should do. yeah, we probably want to see the difference between the mean of the women and the mean of the men. So.
Do you want me to read number 5?
I'll just wait a second for Daniel to.
Okay.
Just wait for Daniel to agree or disagree.
Okay, sorry. I didn't see that.
So Daniel.
All right, sorry. Okay.
So we're talking about the fact that those are not dependent samples. So we should go for the independent samples, and we probably want to find the mean of the women, the mean of the men, and see if there is any difference. So
it's just the fact that, I don't know, it makes me think that the difference of means, we're not actually doing a difference. We're just checking if they're not the same.
okay.
Because if you're doing the difference, you have to have matched pairs. That's when you're doing the difference. If they're not matched pairs, you cannot do the difference. You're just going to see if they are the same or not.
Okay. So a confidence interval with sigma unknown.
But we are not looking at just one mean. We're looking at two. So I'm a bit puzzled,
Okay.
Confidence interval. Okay, the first one, confidence interval for the mean of differences using dependent samples. It cannot be that, because we also have like 15 of one and like 20 of the other.
20 women and 15 men. Yeah.
So we cannot do that. So first and last, definitely not.
So it's either confidence interval for the difference of mean or confidence interval with sigma known. Well, sigma, there's no way how sigma is known, right?
Yeah, that's what I'm saying. First and last, definitely not. It's either the second or the third. Confidence intervals. Sigma is. I don't know. I would say that the third one makes more sense, even if I have some doubts. So we can probably put that and then see what happens,
Yeah, let's try with that one and then we'll see. Isai, do you want to read the 5th?
Of course. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of random samples for 30 customers. A 95 confidence interval for the mean savings account balance of bank customers is found to be 3,402 and between 4,142. Which of the following confidence interval with a smaller margin of error that is than this 95% confidence interval?
Okay.
99, right?
I will say the 4th one. Obtain the balance of 90 banks. Bank customers rather than 30. So bigger sample. What do you think?
Produce some more.
Yeah, the larger the sample, the smaller the margin of error. Because when we have the formula for the margin of error, we divide by the square root of the sample size, if I remember correctly. So if the sample size is larger, our denominator is larger. So that means that we come up with a smaller number.
Okay, so the last one.
Okay. Information. A factory makes propeller drive shaft for 4 ships. A quality assurance engineer at the factory needs to estimate the true mean shaft. She randomly selects 4 drive shafts made at the factory, measures their length, and finds their sample mean to be 1,000 millimeters. Lengths are known to follow normal distribution, whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shaft. Answers for the margin of error, lower bound and upper bound. Okay, so we need the file.
Do we?
Or
No, not really.
Yeah.
Not really,
Okay,
because like
so yeah, the upper bound is will be 1,002 millimeters.
what?
I was gonna say that lower, well, starting from the upper bound is gonna be 1,000 plus 2.
No,
Why not?
because
Sample
we are
mean.
looking for the margin of error.
Oh. Determine the margin of error. Yeah, I was looking into the question 7. It's like the lower bound, the upper bound. Okay.
Yeah, but still, the margin of error is not too
So
big.
yeah. So I thought that's why I was like, why was I thinking about the? Okay. So let's get a calculator.
Sorry?
Don't you need the sample size to find the margin of error?
Yeah,
Because we have
it's
the sample-
4.
Oh,
She randomly selects 4 drive shafts.
Oh. Yep.
yeah, perfect. I was looking for that.
So
So we need to use
the Z.
Yeah, Z
which
asterisks.
is-
That for
which
that
is
it's
1.96.
1.96.
Oh, 1.96.
Yeah, 96.
Sure.
Yeah.
Okay. Time millimeters. Right.
Uh-huh.
Divided by the square root of 4.
That I guess it's 2.
Wow, you're really good at math. Well, which is like times 2 divided by 2, so
Mm-hmm.
it's 1.96.
Mm-hmm.
I got the same thing.
So what did you say, Izzy?
I got 1.96 also.
Okay, yeah.
Yep. So 1.96. That's the margin of error.
Yeah.
And so the lower bound. Okay. So it's like 998.04.
Yeah, we need to put 3 decimals.
Okay, so 040.
Did you guys get the upper and lower bounds? Did you guys use a sheet?
No, you just add and subtract to the mean
Oh,
Mhm.
the margin of error.
You're right. So for the lower, would it be?
So for the lower, it should be like 998.040. And the upper, it's like, well, that's easier, 1,001.960. Right? Daniel, what you think?
Yeah.
You. So, are you good with that, Isaiah? Does it make sense? Wow, I see 2 Isaiah. Woohoo!
It's like Isai square.
Isaiah square, yeah.
Did you guys get 99.04 for the lower bound?
Yeah.
Yes.
Okay, next I'm following now. My bad, I got confused for some reason.
And the upper bound is like 1001.96.960 actually. Okay.
Mhm.
Then you want to read the next one?
To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval has a margin of error of? No.
It's okay,
Okay.
man. It's okay.
So, well, we have to find the sample size. So we have the formula.
Yes.
Standard deviation, it's known, and it's 95%. So we use again 1.96.
Is
And we multiply it by the standard deviation, 0.01.
0.01.
And we divide by the margin of error, 0.0001. And what we come up with, we have to raise it
1.
to the square. Wow. So
it's
38416.
yeah, it's a big number. Is it right?
Mm-hmm.
384156.
No, 38416.
38416.
16.
What formula?
Could it be
did you
that
use
big?
for this one?
What?
What formula did you use?
Use the formula to find the sample size. That it's z asterisk multiplied by sigma, the standard deviation. Then you divide by the margin of error, and everything is in brackets, and you raise it to the square.
It's in the lesson 10 recap.
Lesson 10 recap, yeah.
So okay. The mean area. So we read this mu. Okay. Apparently, of the several thousand apartment in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses for mu are null hypothesis mu equal 1,250, and alternative hypothesis just this equal 1,250.
I'll go for the last one.
Yeah, the last
Well,
one.
yeah, they think it's smaller, so probably, yeah, we should use the last one. What if it's bigger? Okay, save. Question 11. You said you want to read the 11?
Yes. In the statistical test of hypothesis, we say we reject the null hypothesis with a level of significance A alpha if the p-value is less than alpha.
Isai, I cannot hear you.
I think he said the second one.
Yeah, so yeah, I said the second one. It says this.
Yeah.
The statistical test. Okay.
So, go. We agree. Cool.
Okay. Well, a group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers. and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer the question?
Hmm. Well, they can.
So I think it's the first one, right? They don't know the standard deviation of each sample.
Not hearing you again, Izzy.
Oh, I think they don't know the true standard deviation of each sample,
Well,
or unless because it's bell-shaped, is that going to tell you that it should be equal or
no.
what?
Well, it says that we need to know the variance, not the standard deviation, in
Yeah.
order to apply ANOVA. And it looks like they do know that because they say that that are nearly equal. So
Yeah, they just declared that it's nearly equal. So I think it's the third one.
I'm not sure that relying on the bell shape it's gonna be enough though, because we learned that we have to like prepare a QQ plot for each of the samples. So a QQ plot is more precise than a histogram in showing us if it's normal distributed. So I don't know. You know, there are a couple of tricky questions, you know.
Uh-huh. I will vote for this third one, but I see your point, Daniel. But then I, sorry, but then I don't know. So, what's your best guess, Daniel?
It's I don't know. It's either the second or the third.
Yeah, pick one. I said the third. Just pick one. Be the
I'll go with the third
tiebreaker.
one. I'll go with the one.
You go for what?
The third one.
Cool. So it's
All right.
already two for the third one.
Let's go. Let's go with the third one. Let's move to number 13.
Yes. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the new hypothesis is the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant and the 0.05 significance level at the 0.05. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed a type 1 error. Incorrectly used blah blah blah.
Yeah.
Incorrectly used. So type 1 error, that's what I will say.
Mm-hmm.
Cool. Do you want to read the 14, Isai?
Yes. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? Well, they have an inverse relationship, right? So it would increase.
So it will increase.
So the first one.
Yes.
Mm-hmm.
Then you read the 15th.
The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements... Ciao.
Perché ci sono le candele?
Perché sì, perché tengono tante zanzare. Puoi andare a mano che devo finire qui.
Ah, no.
Vai dalla mamma.
Secondo.
Silenzio, per favore.
Ciao, Dio.
Yeah, she's saying hi. Dai, vedi l'amore. So, A random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher? To answer this, test the hypothesis at the 0.05 level of significance. You conclude that you should. So we have to do the whole thing.
Yeah, I was gonna say that. Oh,
Oh, just hey guys, just a moment. I think
yeah.
I'll have to get off and then get back on in a second.
Okay.
Someone's gonna use this room real quick. I'll be back in a second.
Okay.
Papà, vedo che stai studiando.
Sì, amore. Dimmi. Papa. Thank you. Okay, so
So we know the sample mean 1.53.
yeah, we need to find the z-score.
Yeah. Shall we start to count prima Daniel?
Huh?
Cominciamo a calcolarlo.
Let's start talking about it. Yeah.
So. Guidaci, Daniel, guidaci. Parlami.
So we should do the mean minus the the
Papà, ti chiamo mia
X.
sorella.
Noi, cioè, io divento già matto così abbastanza. Cioè, lo so, te lo sto solo chiedendo. Chiudi la porta finestra. Per favore.
No, perché non rispondiamo più. Andiamo, dai.
È il bello della diretta, no?
So we should do x bar minus mu divided by sigma, and that's how we should find z.
Mm-hmm. But we don't have.
Yeah, we have everything. So we do 1.53 minus 1.5.
Oh, 1.5. I was. Okay.
We divide it by 0.17. And that's our z-score.
Yeah.
It's
It's
point.
0.17647. Blah, blah.
Yeah. So then we open the normal probability applet.
Which they kindly provided us.
And what are we? Okay, it's greater. So we're just looking at the right hand, and we are inputting the z-score. That's 0.1765. Bam. And we come up with a p-value of 0.4301.
P-value of what did you say?
0.4301.
Yes, that's what I got.
Okay.
Oh, he's back.
Guys, sorry about that. What time are you guys on right now?
Okay.
I cannot
So-
hear you.
We were talking about, well, this question, and which is the number 15. So we found the z-score. So 1.53, which is a sample mean, minus 1.5.
The last one I was on was
Sorry.
question 15.
Yes, that's what we're talking about.
Okay.
So yeah, we do 1.53 minus 1.5. So the sample mean minus the sigma. No, the
Sample mean minus the-
beat, whatever you call that, and then divided by 0.17, the standard deviation. So we got a number 0.1765. we put that into the probability applet,
Okay.
and we look just for the right tail, the right side. So the area is 0.4301.
So it's greater than the alpha, right?
I
I-
cannot hear you.
I cannot hear you. You say your microphone is really, really low.
Yeah, I don't know what's wrong with my microphone. I think you need
Okay.
a new headphone. What? Can you hear me right now?
Yeah.
Better. Yes.
Better. So you would fail to reject it, is what you're saying? Yeah.
Yeah.
Than the alpha.
Yeah.
Okay.
Do you agree, Gabriel?
I wasn't able to follow that. Sorry.
So what he's concluding is that the right answer is the third one.
Yeah, we failed to reject. Okay. Yes, I agree with that. Thank you. Okay. Question 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? One sample t-test, dependent sample t-test, ANOVA, paired sample t-test, one sample t-test. So we have just two group of
Mm-hmm.
samples, right? So we can do a paired sample t-test.
I don't think so.
Wouldn't it be the independent sample t-test?
Yeah, I believe so. Because if we do the
Oh,
paired
'cause they're not
samples,
same people.
it's not the same people. Like you
Yeah.
could probably do a paired sample if you had 100 male and 100 female that respectively do the same exact
Yeah.
job,
The same exact job,
with the
yes.
same contracts and everything. But I think it's
Yeah.
quite difficult to structure it that way.
So yeah, so it just is independent sample t-test.
Yeah.
Okay,
We're
cool.
halfway through.
Model. Daniel, go for the next one. The 17.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
Huh. That's tricky. Well, I'll say independent, but I'm not sure about it.
But I would go with the depending, because the fact that one sister or one brother is in, it's going to tell us who's going to be in the other group.
Absolutely. Brother and sister, it's a pair. It's like a father-son.
Oh,
or husband and
yeah.
wife. They're-
Yeah, so like the fourth, I was reading the fourth now, is that if you select a brother so as to compare
Yeah, I would go with
his academic achievement to his sister, you must include the sister in your
Yeah, I would go with
total
that one.
sense. Yeah, I just didn't even read the options or just brainstorm. Now that I read it, it makes way more sense. Do you want to read the next one, Isaac?
Yes. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded in dissolved organic carbon Excel sheet. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Right now. But I guess the question says, of 4 types of confidence intervals listed below, which one is appropriate for this situation?
Hmm.
So dissolved organic carbon. Okay. So it's just one set of data. I would go with the first one.
Okay.
Because we only have one set of data.
Yeah, I was looking into that.
You
And
say that it's what do you say it's sigma unknown if it doesn't tell you the standard deviation? We kind of assume that it's unknown.
Yeah,
yeah, I didn't
yeah, we
understand
don't have
much
this.
of what you said.
No?
It's just because I don't know, it's not clear, the sound, when you speak in your mic. So it's difficult to understand. But since they are not providing us with sigma, I am supposing that it's unknown.
Yeah,
Because like the only way that we can know sigma is if they are telling us,
right.
There's no way that I can go and search for the population standard deviation of like dissolved organic carbon on the ground. So it's like
So do we agree with
Ciao papà.
do we agree on the first
Vado a
one?
dormire, tu posso un attimo guardare?
Okay.
okay.
You gotta put some oil on that door, Daniel.
Bene, spostati che sei vicino ai denti.
They don't want to go to bed, so they keep saying goodnight to bed.
Dai, forza,
And it's like the second or third time already.
No, this one was the first official good night.
Oh, it was just
Everything
it was
else,
just like a
everything else was just like coming and watching Dad. It wasn't like.
good.
All right.
So 19. Which of the following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound and upper bound. Oh,
All
God.
right, so we need to get these numbers here and put them one sample t-test.
I need 3 screens. Of course.
I think we need to use the quantitative inference procedures file on the one sample t-test tab. We'll put that all the numbers there. And confidence interval for what?
Ouch.
95% confidence interval. And what are we
Yes.
selecting?
T-test.
95%. Okay, I come up with 11.168 and 15.217.
Yeah. What did you get for the 19? The margin of error.
Well, we have to how do you say that? We have to do the math. So I have.
Yeah, because because I got one, but I'm not sure if it's the.
So determine margin of error. Okay, I thought we had to just look for the higher and lower bound. All right, so let's do this minus this, this minus this.
Oh, no.
2.025.
Sorry, I'm a little behind, guys.
Did you get?
I didn't get that.
No?
Wait a second. Let's see here.
What's your confidence interval, Izzy?
Confidence intervals 11.168 is my lower.
Yeah?
Yeah, me too.
My upper is 15.217.
Yeah,
Yeah.
me too.
And what's your mean?
13.193.
Yeah, that's the same.
Okay, we got the same.
So I think I'm doing something wrong then for the margin of error.
That could be. What are you doing?
Let's see. Okay, hold on. Let's see.
Yeah, there are a couple of ways that you can come up with a margin of error. Like the simplest one is to take the mean and subtract from the mean the lower bound.
24.361.
What?
24.361.
No, I get 2.025.
Yeah.
My mean is 13.193.
Yeah, exactly. If you do 13.193 minus 11.168,
Okay. I got you. 2.025.
Yeah,
Yeah.
2.025. Margin of error. So then the next one is input the lower bound, which we set
11.168 was it? Yeah.
and the upper bound, which is 15.217.
Yeah.
Good. Please the following information for the next 3 questions. A random sample. Sorry, I didn't ask. Can we guys?
Yeah.
Can we move to the next one? Okay, Zay?
Yes.
Okay. So the next question is tab opens. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The date are recorded in this file. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. Create a 95% confidence interval for the true difference prices between the 2 cities. So question 22 said, of the 4 types of confidence interval listed below, which one is appropriate for this situation? So we have 2 group of cars, like 2 group of data. Data is plural?
Data.
Data, okay. So it's not confidence interval, not the first one for sure.
No, I would go with the third one because like they have to be independent. Like how on earth can you pair?
Yeah.
You know, it's like it's crazy.
Yeah. I think
agree.
so. Okay, we all agree. Cool. Next one, calculate the 90% confidence interval for the true difference of mean listing prices between Hummers from Los Angeles and New York. Answer for lower bound and upper bound. Okay, let's download this file.
Two sample t-test. Okay. We're looking at the price, right?
Yep.
The price is right.
Oh, price. Okay, how do we recognize that? Oh, Los Angeles. Wow, it's a lot.
Quite a bit, yeah.
109.
There's like 108 for Los Angeles.
So we
And
use
63 for New York.
Is
we use
your
the
low?
pairs, right?
What?
The sample t-test.
No, the two sample.
Oh, two sample. Yeah, okay, there's another one here. Two sample. So we use Los Angeles as variable one.
I have to.
Yes.
Is it? I'll have to check again.
From LA. Well, I guess. Well,
LA group 1 and New York group 2.
Uh-huh.
Oh no. LA is the group variable one. That's what you said, right?
Yep.
Okay. Oh,
So for my lower bound, I got negative 423.238.
Yeah, I get the same.
sorry. I'm not that fast with Excel.
Got it.
Okay. So what did you guys get?
For the lower bound, we have negative 423.238.
Okay.
And for the upper, we have 5417.336.
Okay. Okay. We got the same, yeah. The lower bound is 423.238. And the upper bound is 45417.336. Okay. Perfect. We go for the next one. Who wants to read it? Do you want to read the next one, Isai?
Yes. Okay. Many studies have suggested that there is a link between exercise bones, and this causes them to get stronger. And the effect of jump on the bone density. There were 3 groups. Rats were selected at random for the 3 groups. A low jump group, a jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks or 10 jumps per day, 5 days per week, the bone density of the rats expressed, the rats was measured. The data are recorded. Researchers would like to determine if the mean levels of bone density are different between the 3 groups of rats listed. Used 0.05 as a level of significance.
Which is the correctly hypothesis test for this situation?
Well, I think it's an ANOVA.
ANOVA, because it has 3 different
Yeah.
categories, and to know if it's different.
Yeah, I would say so.
So.
Okay.
So now we need to calculate the test statistic. Okay.
So I get the test statistic to be 7.978.
The F statistic.
Mm-hmm.
Yeah, 7.978. I got the same.
0.978. Yeah, that's what I got.
Yep. Okay.
The p-value is 0.001895.
Yeah, so it's 0.0018, so it's 0.002.
0.002. Which of the following best express the conclusion of this test? Use a level of significance of 0.05. Well, we are lower than that, so there is sufficient evidence to conclude that the mean bone density between all of the groups are different. The mean bone. The mean bone density is of at least one of the group is different.
So I think it's number 3.
I'm not sure.
Like,
It's number 4. Number 4. I think it's number 4. Sorry, not 3.
Okay, there is sufficient evidence to conclude that the mean bone density of at least one of the group is different from the mean bone density of at least one of the other groups.
I think so, because the null hypothesis when we do an ANOVA is that all the groups are the
same. Yeah.
And then the alternative.
So here I think
the alternative is that at least one is different. That's usually the alternative.
Yes.
So
I will say that density at least one of the group is different from the mean bone density.
Yeah, I think it's the third one because it's the only one that implies that at least one is different.
I agree.
Because the first one, it's not really the case, because if you look at the numbers, we can see that there's not much difference between the first and second group. It's just the third one that it's the one that really differs. So
you will say the third, right?
I think so.
And also Isaiah said the Isaiah said the 4. What did you say?
I said it's the 4th one.
Well, we have sufficient evidence to conclude that the mean bone.
Yeah, we are rejecting the null hypothesis, and like in the 4th one, you're saying that we have sufficient evidence to keep the null hypothesis.
Well, no, it says that there is sufficient evidence to conclude that the mean bone density of at least one of the group is different.
No, that's the 4th one. Sorry. Is it 1, 2, 3? Oh yeah, there's like 5. 1, 2, 3, 4, 5. Okay, sorry. I didn't really look, and I thought it was 4 as usual, and that the 4th one was the last one. So I was saying the 3rd, but I was meaning the 4th. I'm sorry, I'm just tired.
Okay, so is the 4th one?
Yeah, the 4th one.
Okay.
Sorry, guys. Sorry.
Okay, we'll find an issue later. Okay. Information. Use the following information to answer the next 4 questions. Wow, that's a long one. Daniel, can you read that? You read better than me.
Pressures of supply and demand act directly on the prices of an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, An
We know
airline
that.
may discount the tickets or even cancel the flight. Blah, 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 blah. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance, and then again 14 days in advance. The data recorded. Perform a hypothesis test to determine if there is a difference in the mean cost of the non-stop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of alpha equals 0.10 for the next questions. What is the correct hypothesis test for the situation?
Well, what is it? Well, independent sample test, no.
I will go with the last one.
Dependent sample test, yeah.
Okay.
Calculate test statistic. Oh. So we use the pair sample t-test.
Okay, for the next 4 questions, do 14 days minus 20 days, minus 90 days, okay? So be careful to get the right things.
So 14 is the first variance. Okay. What? Okay.
Probably if there's a difference, okay. So I'm not
What was the
equal
question?
to.
Test statistics.
I came up with 1.685.
Oh no.
With the what?
The test
For what?
statistic.
685.
1.685.
Oh, I have a little different.
What did you get? Did you get negative 2.156?
I got 1.641.
That's interesting.
Yeah.
We all got different ones.
Okay.
I put the 14 days on the first row, and then after I put the 90 days. And then they go different.
So yeah, variable 1 is 14 days. Variable 2, it's 90.
Okay.
Try again.
Daniel, can you share your screen real quick and show me all the results you got? Oh, it's coming. Daniel's getting in the darkness.
All right. So, so here are the prices. Okay.
Yeah. Okay. No, just
And I got this one here, and then I put it here. I got the other one, and I put it there. And
But okay. Well, can you just? I don't see. Why I don't see you? Oh, I need to click on your thing. Haha. So the third column with differences. I don't have differences in some column, in some tab, in some cells.
yeah, me neither, because there are flights that were available 14 days in advance, and then they were not in 90, and then there are
like in
others.
first one. So what is the first cell for variable 1? What's the number?
202.09.
Okay, and the variable 2?
234.19.
Yeah, but mine is not giving me any difference in the next cell, which should. Oh, well, yeah, I think I accidentally deleted all the formulas. Yeah, smart move, huh?
Mm-mm.
Dang it. What's the difference? Minus 32.1 in the first cell?
Yeah.
Okay, I'm gonna fix this real quick.
Well, also because like the formula here, it's quite big, you know, because it's like a double if formula.
Whoa. Okay, I fixed it. Let's see. Because it was slightly different than yours. So it's now the T is 1.685.
Yeah.
Okay. The same. Now, what is your T?
I got 0.584 for my team.
0.184?
0.584.
Well, that's a big
How,
difference.
like,
So,
did you put like no hypothesis 0, confidence level? Well, confidence level is not important, but
not equal to.
No, 0 not equal to.
I don't know. Do you want to share your screen? Or... I don't know. Well, we can try to figure that out. How's that possible?
So here's this one I did.
I see why.
So I got all of these data. Oh, wait a second. Data that I'm seeing here.
I think you got it. I think you did not copy all of them, right?
I think I didn't copy these parts either.
No. So we'll find that. Found the error. Click on it.
Okay, I think I just didn't copy all of the data. I think that was.
Yeah, so that was probably the thing. Great.
Gabriele,
Yes.
appena abbiamo finito e sottomettiamo la prima volta, poi stoppa il coso. Anche perché tanto non dobbiamo
Ok.
tanto non dobbiamo pubblicarlo da nessuna parte, capito? Quindi poi stoppa.
Ma va?
Boh. No,
Ok.
così almeno poi se dobbiamo fare delle modifiche o delle cose non rimane nel live, ok?
Beh, se tanto non lo postiamo.
Chi se ne frega, si sa mai.
Ok.
So, Isai, were you able to come up with the same T?
7?
What?
347?
No, we have 1.685.
I know what you're supposed to do. I must just be making like some mistake on Excel, but I think you guys are right. You said it's 1.68?
Yeah, 1.685 we came up with.
Sorry guys, I gotta blow my nose real quick.
I didn't get, Isai, if you got the same result or.
I get the same result. I got 1.636.
6?
1.636.
1.636? Wow, that's close, but it's not the same.
Yeah. I was that close, but then I had to correct something.
Yeah.
I wonder if you have all the formulas right. That could be it. Something.
Sure.
But good luck in checking all of them.
So what's the p-value that you came up with?
Yeah.
I have 0.0956, so 0.0096.
Yeah. You see, it's slightly different, because like the one that you got, Isai, would cause you to fail to reject the null hypothesis. But the one that we got would actually make us reject the null hypothesis because it's 0.096. So
That's
it's weird.
That's fine. Just,
What did you get? Let's do this. Let's see. I'm gonna tell you the mean that we got for the two variables, okay? And see if it's the same. Okay.
hold on, just one moment. Just like, let me redo it one more time.
What time is it? Così le 10. In an hour and a half, I have another meeting for another class. I'm spending my evening and my night out on the balcony. Yeah.
Not bad.
It's okay because there are not many mosquitoes yet. But I will not be able to do that in a couple of weeks' time because it will be filled with mosquitoes and I will be just scratching myself all itchy. That's not nice.
Tell me your mean.
All right, so the mean for variable 1, it's 268.858.
Yeah, that's what I got.
The mean for variable 2, it's 244.064. And the differences are 24.611.
I got 24.515.
So you have the same mean, but you have a different difference.
Yeah.
That means that you probably have some formulas in the difference column that is wrong, as I had before.
I don't know what it could be.
I accidentally canceled some cells, and so I canceled the formulas, and that was getting a different difference, but having the same variable. So
Because, well,
well, I did again the average, not trusting the formula. and doing the average of the differences, I come up again with 24.611. So there has to be something in that difference column. All right, let's read them, you know? It's like, whatever. I will read to you, you know, from the top, all the differences in the column of the differences, okay?
I'll be back soon.
Okay, easy. And then you tell me
Yes.
when.
Okay, so here, hold on. Daniel.
Yep. You mean for what? For the differences?
For this right here.
For the differences? Mean for the differences is 24.611.
I got it now. I got it.
You got it? So what's the T?
1.685.
1.685.
Yes, and then
Okay.
my lower bound is
No, we just
negative-
need the p-value. P-value
Okay,
it's
well, I got it.
0.096.
0.096.
Okay. Okay, so then question number 32, I would go with the second one. Okay. All right, let me
Basically, yes. Okay.
let me just call that. Calling my brother. That's like, come on, man.
I'm here.
Hey, I'm sorry to bother you, you know. Sorry.
Yeah, you are bothering me. So.
All right. So
not you, Isai, just that.
All right, so we have finished, okay? Quindi
Yes.
stacca un
Great.
po' il coso, dai. We're done.
Okay.